This video is meant to introduce you to the idea of a typed report if this is something you haven't encountered before. So in Physics 1102 or 1220 at Richmond campus, we have you turn in every week your notebook, a typed report, an Excel spreadsheet, and you might also turn in a graph. Now, if you took Physics 1101 or 1120 at Richmond campus, then that probably all sounds familiar because that's what you were doing in those courses too. But if you took those courses at Surrey campus, then you maybe aren't familiar with what, say, a typed report is. The good news is that what you're going to put in your typed report is some of the stuff you used to write in your notebook. So it's not really any more work, it's just a different format. So to explain what goes in your notebook versus your typed report, I'm going to use an example from the Richmond Physics 1101-1120 lab manual. So to begin with, in your notebook, you're going to write down some identifying information, the title of the experiment, the date, your name, and your partner's name. The next thing that goes in would be an objective. So that's just a couple of sentences saying what you're trying to accomplish in this week's experiment. So the next thing you would have put in your notebook would be a theory section. You don't need to do that in this case because the theory section is only going to go in your typed report. So this stuff in the red box, you're just going to skip over. So you write down your identifying information, the objective, and then you skip down and you put your apparatus procedure section next. The apparatus procedure section should just be a reference to the experiment in the lab manual. So you'd say see pages, whatever, and give the full title of your lab manual. Next, you're going to put in your data. So if you've got tables, please label them and make sure that every piece of data that you have, whether it's in a table or not, is labeled in words with an uncertainty and units. If you make an error, cross it out with a straight line and put the correction nearby. Both the mistake and the correction need to be readable. If you correct data, do the same thing, except you should also put in a note about why you changed your data. And finally, you should always explain your uncertainty choices. So did you have an instrument uncertainty due to your digital multimeter? Did you have a reading uncertainty due to a ruler? Explain why you chose the uncertainties that you did on your data. And that's the last thing that you're required to have in your notebook because everything else is going to go somewhere else. So scrolling down a little bit, the next thing you might be used to putting in your notebook would be sample calculations. You're going to be putting all of your calculations into Excel and handing that in as part of your lab report, and I'm only going to mark the Excel work. So if you want to put in sample calculations just because you like working things out by hand, feel free to, but I'm never going to mark that. I'm only going to mark your Excel work. And the discussion, which would normally be the last thing you put in your book, is only going to go in the typed report. So again, you don't need this. So in your notebook, all you need to put in is the identifying information, the objective, an apparatus procedure section, and then your data, including an explanation of why you chose the uncertainties that you did. So now let's go and have a look at what a typed report looks like. So here's an example typed report. So the typed report starts out a lot like your notebook. You begin by putting down your identifying information. So title, date, your name, and your partner's name. Then, again, you put in your objective. And the objective in your typed report can be exactly the same as the one in your notebook. The next thing you put in here is your theory section. And the theory section is only going in your typed report, so this is not going to be in your notebook. As usual, your theory section should be in words what the theory for the experiment predicts, then any equations that you're actually going to be using in the experiment with the variables defined, and then you say in words how the experiment is going to verify the theory. So are you going to get a graph of a certain shape? Are you going to compare values to see whether they agree with expected values with an uncertainty? Stuff like that. And then finally, you list any assumptions or approximations that you made in the experiment. And one thing to be aware of is that you do need to typeset your equations properly. So I'm going to go over to a blank document and show you how to do that quickly. So if you want to insert just one symbol into a sentence, so say for example, the angle theta, and you want to insert a theta, you go up to the Insert tab at the top and come over here and you click on Symbol, and it'll give you a little box of symbols. You may or may not see the one you want here, so go ahead and click More Symbols. And one thing to be careful of is to make sure that your font is actually set to symbol font. So if your font is set to symbol, then you should see all of the Greek letters here, including the lowercase ones down lower. And if you keep going, you'll find special symbols like the degrees symbol or the plus minus symbol or the time symbol. So you can just go find the one you want, theta in this case, and then click Insert, and it'll insert it into your document. So the angle theta was 5, and say I want a plus or minus symbol. Again, Insert tab, Symbol. Look for plus minus. I can insert that one directly, 1, and then I can put in my degrees symbol the same way. Click Symbol. I've got degrees here, but again, I can click more symbols if I don't see it, and then just scroll down to find it. Click Insert and put it in my document. So that's how you insert special symbols. If you want to put in an actual equation, again, you go to this Insert tab, but then you click on Equation here. That will put this box into your document, and you can now type in your symbol. And you're going to use these menus up here, and you also have special symbols over here. So for example, I can type F equals, I can put in a square root using the menu. I can click into this box and then go script and give it a superscript, and now I can say something squared, for example, so x squared. You can use the side arrows on your keyboard to get to different locations. You can also put in fractions, and you click in the boxes, type in whatever you want, and again use the side arrows to get out. So that's a side arrow to get out of my fraction. Another side arrow gets me out of my square root, and I can type other stuff as well. If you want brackets around something, you can highlight the thing you want brackets around and click these brackets here, and those will automatically resize. So something big will have big brackets, and something small will get small brackets. And then you can click outside the box to go back to editing your document. If you want to go back and fix things, by the way, just double click and you can get back into that mode. So again, to insert an individual equation, you go to the Insert tab, click Equation, and then fill things in. By the way, as I said, there are special symbols up here. If you don't see the one you want, you can click on this little arrow at the bottom and it'll show you a few more. If you're still not seeing what you want, for example, there's very limited Greek symbols on this menu, then you change up here from Basic Math, click on that little arrow, and you can go to Greek letters and get the whole Greek alphabet. So now I'll go back to the typed report. So after your theory section, you will again have your apparatus procedure section. Again, this is going to be just like the one in your notebook. Refer to the page number and give the complete title of your lab manual. After that, the next thing you put in is your results section. So this would just be a few sentences listing your important results from the experiment. If you're not sure what your important results are, go back and reread the objective. That usually gives you a good clue. Note that when you list your values, it should be the value, its uncertainty, everything rounded off correctly, with units. After you've listed your results, then you can go into the discussion part of the typed report. Now in Physics 1101, 1120, the discussion section was very rigidly defined and you had to have certain things. So you had to talk about accuracy. Did this value agree with that value with an uncertainty? You needed to talk about the precision of your experiment. And if you had a graph, you had to talk about whether it was the expected shape. Now in Physics 1102 and 1220, you've leveled up. You're expected to write a slightly more sophisticated discussion than that. Talking about agreement and precision is a good place to start. However, you're often going to need to talk about more than that, and what you should talk about will vary from experiment to experiment. So what I recommend you do is make sure you've talked about agreement and precision, and then go back and reread the objective of your experiment and make sure you've addressed anything that was in there in your discussion as well. So the stuff you learned in Physics 1101, 1120, it's a good place to start, but you will often need to talk more about the physics in order to get full marks in this course.